What's up, guys? Today I'm doing a video on logarithmic and exponential word problems. And really we're just applying everything we've learned up to this point. There's nothing new here. We're just kind of applying it to a word problem. And really what you should start realizing at this point is that exponential and logarithmic problems are really two different ways of looking at the same issue. Okay, so here's a situation. You've got a car that's worth $30,000 and it loses 10% of its value per year. They want us to do three things. Write an exponential function for the value of the car by year. Then we're going to also write a logarithmic function for the value based on the year. And then after how many years will the value be $5,000? Okay, so for the first part, here's what we want to do. Okay, I'm going to write, this is kind of what we did back when we were first talking about exponential word problems. Okay, so we're just going to say the value of the car is equal to $30,000, that's the starting amount, times 0.9, because remember that's 1 minus 10%. Okay, and that's to the t power, where t is the number of years. Okay, and that's really all he asked us to do. Now you could answer a lot of questions, and we did back in the exponential part of the unit. We did actually answer a lot of questions like this, and then you could plug in different values for t and get different values. So I could plug in 1 year and it would be worth 90% of 30,000. I could plug in 2 years, it would go down more. 3 years, it would go down more. But then to answer the question backwards, if I want to know when was the value going to be equal to a certain amount, like C here, where it says when will it be worth 5,000, this wasn't good enough. You could kind of use the table and you could go through the table and see where it got to be less than 5,000, but you don't know exactly when it's going to be equal to 5,000. You need logarithms to answer that question. So we could actually just rewrite this as a logarithm and then answer the question that way. And that's what we're going to do. So for question B, we're going to actually write out this formula as a logarithm. Okay. Well, the first thing I would need to do is divide both sides by 30,000, because you got to get the exponent part by itself. Okay. And now that I've got the exponent by itself, I can rewrite this as a logarithm equation. So now I'm going to say log base 0.9. The base is still the base. The other two parts switch. So t goes to the other side, and this part becomes the exponent. Well, not the exponent in this case. It's what's inside the logarithm. So now I've got time by itself. Instead of having v on one side of the equation, now I've got t on one side of the equation. So what this allows me to do is now, instead of plugging in t to find v, and you can only really plug in, obvious values for t, here we can plug in whatever we want for v and get the answer for t. So now I can plug in 5,000 for the value and find out what t would be. Okay, so that takes us to part C. When will it be worth $5,000? Well, I can use my equation. T equals log 0.9 of 5,000 divided by 30,000. Now you can put as much of this as you want in the calculator, or you can kind of work it out however you would rather do it. I think I would probably just go ahead and put this in the calculator. Now remember, you got to use the change of base formula when you do this, because you can't type log base 0.9. So we're going to have to do log 5,000 over 30,000. Okay, divided by log 0.9. And remember, the base is 10 in this case. That's the log that we can put in our calculator. And so that's what I'm going to do right now. So I entered it in my calculator, and what I got was 17.0059. So I'm just going to go ahead and round to the nearest tenth, which is still 17.0. That's how many years it would take for the car to go from $30,000 down to $5,000, losing 10% of its value per year.